Welcome to Dunwoody Mechanical Engineering. This is MENG3130 Thermodynamics, and we're going to work through this problem here using Interactive Thermo from Moran and Shapiro. So in this problem we have a rigid container that has 20 cubic feet per volume, 75 pounds of R134A, and it's for some reason just sitting outside, so it heats up over a 6-hour period. And we know the initial condition. We have a 100 pounds per square foot, per square inch, and then we know later in the day that we're up to 100 pounds per square inch, more than 100 pounds per square inch, but we're at a saturated vapor. So we're looking for the initial temperature in degrees Fahrenheit, and then the final pressure in PSI, and how much heat we added to that over the course of the day. So let's get into it. Here's our, oh, that's not the wrong one. There's our Interactive Thermo. So first off, so when you fire this up, you see the workspace here, toolbars up at the top. First off, we'll make sure we're in English units, and I do want PSI for this one. We'll do it in degrees Fahrenheit. Fantastic. So then next we'll get to some properties. So I'll say this is material 1, and this is R134A. So there we go. And first off, I know the pressure, right? I know the volume, so let's put a few of those in here before we even get there. So P1 is 100 psi. V, I'll make a capital V, is 20 cubic feet, and our M is 75 pounds. So V1 is going to be V divided by M. V2 is also that same thing. So we have our specific volumes, we have our pressure there at the beginning. So part A, we're looking for the initial temperature, so let's get to that. So if I go T1, it's going to be a saturation at that, so I can just grab this equation here. So that should get me that. And then, so we've answered part A, then the final pressure in PSI. And so at state 2, I'm just going to switch this over to 2 here. And now we need VSAT 2. It's going to be this thing. We know our P2 is something we don't know. X2 we do know. X2 is 1. Right? We're a saturated vapor, so our quality is 1. We don't know P2, but we know that VSAT 2 is also V2. Right? Same specific volume. I have that back up there. So we should be good with that. So now we should be able to find the final pressure. And then last, the heat transfer. So how do we find the heat transfer? Well, we need to find our mass times our change in specific energy. So our initial, so U2, oh, I can probably just leave that. Oh, getting crazy with the keyboard. U2 is USAT2 at that condition. So I'll grab that. And U1, if I go back to that, it's going to be, we should be a 2-phase mixture at that initial condition. U1, okay, so I'll just grab it from our pressure and temperature. I was assuming it was saturated there, but I should verify that. So I could also do that. Let's maybe go back to that as saying as V1 temperature, pressure there. Let's just compare. I don't know my quality. V1, I need temperature, pressure. Where am I missing? VSAT, if that is temperature and quality, I could compare that here. So let's do that as well, just to confirm. So VSAT 1 equals V1. Then we'll report out what X1 is. If it's less than, if it's 0, then we may need to confirm that, or if that doesn't solve, we may need to confirm that. So we have U1, we have U2, so then our Q equals M times USAT2 minus U1, and actually I might need USAT1. Actually, that's what we'll do here. So plug that in here as well. So that's USAT1. Alright, I think we're good. Let's go ahead and solve that. Didn't get any errors there, so let's see what we get. So pressure is 174 pounds, great. Our U1 was that, USAT1 was 73. Let's check X1 was 55%, so that's good. So we were a saturated mixture, so my equation here, USAT2 minus USAT1 is valid. VSAT, all of those are the same value, fantastic. And so then our overall Q was 2,581 BTU. So that should take care of it for us.